Hello everyone, how's it going? My name is Dan the Tutor. Today we're continuing our journey through conic sections. In this video we're going to be talking about the ellipse. If you remember, each of these four conic sections are if you put a plane through a cone shaped like this. And so in this video we're going to be looking at the ellipse, which is really just an oval as far as we're concerned. Now in the last video we did circles, which was pretty easy because we had a very simple equation. You'll see where ellipses are the first ones that start to get really difficult with the equations, and that's because it follows the following formula. Quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. And the key here that makes an ellipse different than a circle is the fact that a cannot equal b in order for it to be an ellipse. And so now ellipses are generally going to look something like this. Again, they're basically like an oval in shape. The center is always going to be at h comma k, exactly like the circle. Ellipses do not have a radius though. There's no such thing as a radius for an ellipse. Instead, what we're going to focus on is the focus. And what the heck does that mean? Well, basically there's 2 points on every ellipse. In this case, it's probably about here and about here. And if you look at these 2 points, which are called focuses or foci, plural. So these are both focuses. I'll put foci in parentheses. Basically, what's special about the focus is that if you were to draw a line, let's look at a point. Let's say this point right here. If you were to draw a line from this focus to there, and then add the distance of that point to there, it's going to be the same distance no matter where you're looking at. It's equal to 2a. In other words, if I had my two blue lines together, I'm going to get a distance of 2a, where again, a was the distance in this formula here. Of course, that's if the parabola looks horizontal like this. If you have a parabola that looks vertical like this, then the distance is actually equal to 2b. But I'm not going to talk about that right now. I think this is confusing enough as it is. So let's just look at the horizontal case first. So like I just said, those two distances added together are 2a. If I choose another point at random, let's say that point right there, and I draw two green lines, one to each focus, and I add the two green lines together, if I had a ruler, then I would get 2a again. The distance is always the same between the focus. And that's only true at the focus and no other point on the ellipse, which is why it has a special name. Now continuing back with the equation, the only way you get this is a horizontal ellipse. The only way you get a horizontal ellipse is if a is greater than b. So for instance, if a was 6 and b was 2, then a is greater than b, so it'll be horizontal. And it's going to be vertical whenever a is less than b. And if you ever have a equals b, well, that's a funny scenario. That's called a circle, which is why we're not talking about this case in this video. Another thing to note, back to the equation, this has to be a 1. In other words, if I tell you that instead of 1 I put a 10 here, then your first step is dividing everything by 10 because that needs to be a 1 in that spot. We would need 1. And then the last thing I'll say is there's 2 more terms we ought to know, the semi-major and semi-minor axis. The semi-major axis is the distance from here to here. This is called the semi-major axis, and it is equal to a. Again, for the horizontal, for the vertical it's b, but this distance is literally a, which means if it's centered in the middle, which I didn't draw it the best, but let's just say it is, that distance is also a. So a is the semi-major axis, and b is going to be our semi-minor axis, and that's the distance from the shorter edge to the center. So we have the semi-major and semi-minor axis. That's b in this example. Again, they can change whether I'm looking at a vertical or a horizontal ellipse. And so with that, we can look at our first question. Let's say I have x squared over 9 plus 4y squared equals 1. The first thing we ought to do is try and find a and b. So you'll notice this one's already in the form that I want. This is kind of in that form, x minus h squared over a squared, where h is just 0 and a is the square root of 9, so 3. That's great. Now, 4y squared is not exactly in the form that I want, because I want y squared over b squared. So in other words, when that 4 is not where we want it to be, it's because it's in the denominator of b. What do I mean by that? What I'm saying is that b squared is equal to 1/4 because it's in the numerator when it needs to be in the denominator. So you flip that for the b squared. So let me just repeat myself one more time. If this 4 right here was in the denominator, then b squared would be 4. But since it's in the numerator, it's in the denominator for b. And when we take the square root of that, the square root of 1/4 is 1/2. So that's my value for b. So I have a equals 3 and b equals 1/2. As a matter of fact, we have a pretty good idea of what this parabola looks like already. 3 tick marks to the left and right because that's the distance a is from the center, which is 0. So there's a coordinate point here and a coordinate point there. We'd call that the vertices of our ellipse. And then we've got 2 more at 1/2 up and 1/2 down. So you're going to notice this is a really skinny ellipse, but that's fine. I don't judge here. And this is basically what our ellipse is going to look at. As you can see, very horizontal. That's because A was greater than B, and the vertices are here and here. I know there's also vertices here and there, but typically we don't draw those because we care about the semi-major axis, because that's where all the fun stuff happens, not the semi-minor axis. And then the last question is, how do we find the focus? So one thing I actually didn't tell you is how to find the focus. To find that, all you're going to do is use the equation f squared, which f stands for focus, equals the semi-major axis squared minus the semi-minor axis squared. Okay? And why can't I say a squared or b squared? Because it changes for every problem, whether it's semi-major or semi-minor, for a and for b. In this case, the semi-major is a and the semi-minor is b. So that means the focus, f squared, equals a squared, which you said was 3 squared, minus b squared, which is going to be 1/2, again, squared. So f squared equals 9 minus 1/4. Getting a common denominator of 4, that's going to give me 9 times 4 is 36/4 minus 1/4. Some of you are really bad at subtracting fractions. Really is concerning, but I'm assuming you know how to do that, hopefully. So we'll get 35/4 as f squared. Take the square root of both sides. You will get f equals the square root of 35, which does not reduce, divided by 2. And there is our focus. Actually, it's plus or minus, because remember, there's 2 foci in any ellipse. And there we go. By the way, the foci and the semi-major and minor axis, in other words, F, A, and B, are all in relation to the center, which is important to remember if my center is ever not 0, 0. And we'll worry about that in a later problem. Okay, so that's it for the first one. Now for number 2, I've got 25x squared plus y squared equals 25. The first thing you should say when you see this is, hey, this needs to be 1, and it's not 1. So that means I'm going to divide everything by 25. And when I do that, I now just have x squared plus y squared over 25 equals 1. And this is great because now I can find a and b. If you notice, a is just going to be 1 because it's like a 1 in the denominator, and b is going to be the square root of 25, which is just 5. So there we go. I got a and b. I know that b is greater than a, and so that's going to be a vertical ellipse this time. And I also know the center is at 0, 0 again because there's nothing next to this x squared or y squared. So basically, I already know most of what this ellipse is going to look like. 5 tick marks up and 5 tick marks down, and then 1 to the right and 1 to the left. There's my vertices here, 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 and here. And then I just have to connect these dots in kind of this football shape. Not the best ellipse, but you know what I was trying to do. And again, I would say my vertices are this point up here and this point down here. And that's because we care about the semi-major axis for my vertices. And now to find the focus, or the foci, then all you got to do is f squared equals semi-major, which this time is b squared, minus the semi-minor, which this time is a squared. You'll notice it should always be the bigger number minus the smaller. If you ever mess up, you'll get a negative answer for this part, And when you try and take the square root of a negative number, like -2, your calculator will say error. All that means is you had the wrong order, and it should be +2. So that's a quick and dirty cheat if you ever mess up. So now f squared equals b, which we said was 5 squared, minus a, which we said was 1 squared. So f squared equals 25 minus 1, so 24. Take the square root of both sides. That's plus or minus. F is going to equal, well, let's see, 24 breaks up into 4 and 6, and 4 is a perfect square root. So that will then get you 2 root 6, plus or minus 2 root 6. And again, that is in the y direction. So in other words, if I were to actually write out my coordinates for my foci, I have 2 coordinates. The first one is at the center, 0 for x, and the y coordinate is +2 root 6. And then the other foci is at, again, x is 0, y is -2 root 6. And there we go. That's everything I would need for that problem. And now let's just do one more with an ellipse. I have 4 parentheses x minus 6 squared plus 25 times the quantity y minus 1 squared equals 36. This will be the hardest one yet. So once again, that 36 is not 1, so I've got to divide everything by 36. I'm going to try and simplify this as much as possible, but it might not work out. In other words, 4 divided by 36 gets us to 1/9. So this is like x minus 6 squared over 9 plus 25 over 36 doesn't simplify at all, so that stays the same. And then the right side's just 1. Now we need to be really careful with what we put for a and for b here. I think a is pretty easy. A is just the square root of 9, which is 3. B is much harder. So remember what we said earlier, this 36 is exactly where we want it to be, but the 25 is in the opposite spot. So if you remember, that means the 36, well, at least for b squared, the 36 is in the numerator, and the 25 is in the denominator. And so now when you take the square root, yes, there's technically a plus or minus there, but I'm just going to ignore this for a second. B is going to equal 6/5 when I take that square root, because the square root of 36 is 6, and the square root of 25 is 5. And we already know it's plus or minus because when we draw our ellipse, like I'm going to right now, 3 tick marks to the right, 3 tick marks to the left. It's in both directions. And 6/5 is really like 1.2. So it's a little bit more than 1 and a little bit less than -1. However, before I actually mark these tick marks, remember that I moved the center this time. The center is now at 6, 1, and that's because the x minus 6 becomes +6, and the -1 becomes +1. So really the center is at the point 6, 1. And so if I want to find the vertices for this one, again, along the semi-major axis, which A is the semi-major, A is greater than B, 3 is greater than 1.2. That means that my vertices are going to be, where's my center? 6, 1. So it's going to be 6 minus 3, 1, and the second vertice is 6 plus 3, 1. If you want to know the other two vertices from the semi-minor axis, that's going to be 6, 1 plus 6/5 and 6, 1 minus 6/5. But I don't really care about these as much as these vertices from the semi-major axis. And then the last thing we need to do is find the focus or the foci. So that's going to be f squared equals, again, the semi-major this time is a, so a squared minus b squared. And f squared equals, a was 3 squared 9 minus b squared 36 over 25. Yeah, that's a monster. But getting a common denominator of 25, 25 times 9 is 225. So 225 over 25 minus 36 over 25. That's my f squared. Just subtracting these fractions, I'm going to get, that is 189 over 25. And then we take the square root of that, and you're going to see that the square root of 189, I mean, it's divisible by 3, but I'm just going to keep it as root 189 over square root of 25 is 5. And there's my focus, plus or minus, right, along the semi-major axis. So in other words, my foci, if I'm going to give coordinate points for these, remember the center was at 6, 1. So the first foci is 6 plus root 189 over 5. comma 1. And then the second focus is at 6 minus root 189 over 5, comma 1. And there we go. By the way, there are no foci along the semi-minor axis, semi-major only. And that's going to wrap it up for ellipses. I know this was much harder than the last one, but go ahead and do some more problems on your own to practice, and I think you'll be fine. So in the next video, we're going to cover hyperbolas. Stay tuned for that. Until then, have a great day, and I'll see you there. Bye-bye.